everybody. I hope you're back from lunch. You're all good to go. So when I say the word intelligence, what comes to your mind? What do you imagine? Most of us, we imagine something like this that you see. It's a human brain. Or maybe perhaps you can also imagine something like a powerful machine, like an artificial intelligence that is trained to think like us, right? So in most cases, what we build is a picture of a big brain with a central command center. But today, we are going to begin somewhere really, really small, nothing big. We'll start with this tiny organism, which is called the pond snail. It has a nervous system, which is very similar to a brain, but it's like the size of a grain of rice, okay? So imagine the size of it. But yet, with this tiny little brain, it can do amazing things. It can learn, it can remember things, it can take decisions, and behold, it can also show signs of anxiety and loneliness. You don't believe me? I know it is very unbelievable. And for the first time, when I started working on these systems, I also did not believe these things, that these snails can actually do so many different kinds of things. But what these organisms have taught me is something very simple. That is, intelligence is not something that we humans invented. Intelligence is something that nature and life discovered long, long back. But today, why are we talking about it? Why are we talking about intelligence? Because we are obsessed with this world now, right? We always are thinking that, oh, is artificial intelligence, how bigger and better is it going to be? Is it going to be like, it is going to replace us humans? Can it think like us? Can it take us our jobs someday, right? But every time we think and compare this, we always have a reference with us, right? Like humans. We always compare this artificial intelligence to humans. And this kind of narrows down our idea of intelligence. And it blinds us to all the intelligence that is out there in nature, which nature shows us in all its different forms and functions. So now today what I'm going to do is, I'll pose a question slightly differently. Let's think of intelligence of something that is not what we have, but it is something that we do, okay? So it's the power to actually learn from experience, adapt to change, and take decisions under uncertainty. And these were the very few things that I was also really interested to understand. I had a very simple question that whether intelligence is the only thing that sort of emerges, is it just residing in our brains, or does it exist outside? Okay? And that is what led me to sort of start studying these snails. What I do as a researcher is that I try and understand how living systems think, not just with big brains, but with very simple nervous systems, and sometimes no nervous systems at all. Okay? So this led me to answer this question. I sort of started my journey during my PhD in Bangalore, in Indian Institute of Sciences, but I had this idea of cognition and finding out about intelligence, and that kind of led me to Canada, where I got a chance to work on neuroscience. And what the snails taught me was something remarkable which I had never expected to find in such tiny organisms. So these tiny snails, they have a nervous system which is just 25,000 neurons, compared to us, where we have 86 billion. Okay? So think of the scale of difference there. But with this simple system also, they could do a lot of things. And we'll start with something very simple and very familiar to all of us. Okay? So let me just ask you, have you ever like sort of tried something new, okay? Like a very new food which you have never tried before. And then after some time, let's say you tried that new food for lunch, and at night you fell sick. Like you are vomiting and you have a digestion upset. You have always found that, okay? So when that happens, when you fall sick, next time when you encounter that food, do you want to eat that food again? Maybe not, right? Exactly. We all have this experience. How many of us have had this experience? I definitely had, yeah. So most of us tend to avoid these foods, okay? Because we form this memory that it has made us sick. And it's the exact same thing that these snails can do. They remember when they have eaten something new, and if they have fallen sick, they make this really powerful memory or connection between these two events, even if those events are spaced out across time, okay? They associate it, and then they tend to avoid that food so that they can survive better out in nature. So they make this powerful memory, and they decide to make a choice of not to eat that food. And not eating is a very costly choice. So they have to be smart to make that decision, okay? But it's not just that. They can do some things which are much more complex than this. Let's imagine you all going on a hike, okay? So if some of you like hiking, let's imagine that you're going for a hike, and the weather is really nice, there are birds chirping, it's a really clear sky, very sunny day. You have hiked a lot, and you feel tired, okay? So you also are carrying something to eat. So you sit down in a quiet place, very nice ambience, you take out your sandwich, you're just about to bite it, and suddenly a bear comes from nowhere. You run for your life, right? So your brain at that time is forming this memory. It is not just that your brain is saying that, oh, bears are dangerous, but it remembers this entire situation of these birds chirping, that entire ambience, you sitting down to eat, all of that together. Now the next time you go out hiking, and you are in a very similar setting, okay? You're about to have your lunch, but you feel a slightly bit uneasy, because now your brain makes that connection and tries to tell you that, are you sure you want to have that lunch? There was a bear last time when you tried to have it, okay? So you think a bit, you pause, you might not have lunch at that place. So this kind of a complex memory system also forms in these snails. When danger comes along with some food, with something they like, they form this very strong association. And it is not just about that, yes, there is a threat around or there is a predator, but they'll associate that food as well to it. And this kind of learning is called a configural learning, where the brain forms these different kinds of cues that it gets in the environment. And the next time that happens, any one cue can trigger that feeling of threat. So the snails feel exactly the same way, and they show these kinds of defensive behaviors, okay? When the food comes next time, even without a threat, okay? So this tiny system has this really powerful mechanism to predict things as well. It's not just that. I told about anxiety. And yes, the snails do show remarkably similar signs of anxiety, how we show these. And what anxiety is, it is just that when there is no immediate threat right in your surrounding, but you still feel very defensive. You still have that sort of a feeling of danger, that yes, there might be a threat around, even if there isn't, okay? And your heartbeat starts increasing, it's racing, you are very hyper alert at that stage. The snails show exactly these kinds of signs. Even when danger is not exactly there, they'll have this kind of really heightened breathing. They will be super alert. They're not going to eat at that time. They're not going to explore. So they are being very vigilant. And the most astonishing part here is that what we did during our research is we tried to give the snails the same anti-anxiety medicine or pill that you and I can pop up, okay? And it reduces our anxiety. It does the exact same thing to the snails, which tells us that their nervous system also works in very similar ways like ours do. What we found, another very interesting thing, is that these tiny organisms can also feel lonely. When we isolate them from their group members, they go through something which is very similar to loneliness. They'll not want to eat, they are not going to learn, so they feel really lonely. And how do we cure them? How do you cure yourself if you're maybe feeling lonely? You want to go out and hang out with your friends. You want to spend time with your friends, right, who you know. And that's the exact same thing, how these snails can recover. If we put them back, group them back together with other snails who they know, who are their friends, then they recover. But if I put them back with strangers, they don't. So even these tiny organisms can understand who they know, who they don't, if they want to sort of showcase, if they want to be, whether in a crowd or just with friends who they know about. Very similar kinds of mechanisms that we express, okay? So these are all very remarkable things that this tiny organism taught me. And that kind of opened my mind to understand, yes, these organisms or intelligence doesn't have to be confined in one central big brain. It can be found in all across life forms. And this one, I just want to showcase, it's not my work, but there has been a lot of work on these very remarkable organism, which is a single-celled organism. It's called slime molds. They are basically like rock stars of neuroscience, okay? It's one single cell. They have nothing like a brain, nothing nervous system, no neurons, nothing at all, okay? But with this very single cell, they can solve mazes, they can remember what kind of food they have eaten, and where to find the shortest path to the food source. They can also remember where danger was. And there's this remarkable study that is done by scientists from University of Hokkaido in Japan, where these slime molds, they built the entire railway system of Tokyo, okay, within 26 hours. It's the exact same system that we produced by like working over it over days. We'll need a machine to work on this. But these organisms, single cells, no brain, no neurons, could solve the problem in just 26 hours. What about plants? What do you think of them? They are everywhere. You see them every day in your school, in your home, all across around us, right? They don't speak. They can't, you think that they can't maybe communicate. But there's a very pioneering Indian scientist, Jagadish Chandra Bose. He was the first one who actually thought that plants can also signal. They send electrical signals throughout their bodies in the same exact way how our neurons function, okay? It's the same system of electrical impulses that works in these plants. And he found that plants also respond to different kinds of stimuluses. He wrote a book called The Nervous Mechanism of Plants, and it's like, it's a coincidence that like this year, it's the 100th year of that book, and I'm standing here and talking about it. So during those times, early 1900s, he has spoke about plants and how plants can also show intelligent systems. And today, there are a lot of scientists across the globe, scientists from Spain, from Italy, from Edinburgh, who are working on plant intelligence. Because plants can communicate across their root system. They can send out chemicals to communicate with their neighbors and warn them if there has been an attack on themselves, okay? So entire forest systems can all work together. They can communicate and build networks and solve problems and shoo away their attackers. They also remember what kind of stress they have faced. If there has been a water stress, a drought stress, they can communicate those things and act accordingly. So they are learning from their experience. The octopus, they are the greatest examples of intelligence that is distributed. It's not just in one place. So they have a really big nervous system, but 2/3 of their nervous system is actually in their arms. So all the 8 arms of the octopus can actually think very independently, okay? They don't need to communicate with their main system or the main command center. They can do things on their own. They can all work independently and decide on things. So nature has these different kinds of designs of intelligence. It is not just one design, maybe how we think, okay? And that's the main takeaway that I want you to take from this talk. We started out with thinking of intelligence and on some organism like the snails, the slime molds, which we don't even ever notice, okay, during our everyday lives. But they show things, sort of tells us that we should expand our idea of intelligence. We should expand that definition. And if you do that, you are going to sort of learn to innovate much, much better. You can sort of think of systems which you can design in terms of technology where this distributed intelligence can work together. It will be very energy efficient, very optimal systems. And it also helps us to understand where we are in nature, what part we play in this whole universe, in this whole system, in the whole ecosystem. Because it's not just us, we are not the most superior beings here. There are all other systems out there in nature which can do very similar things to survive like we do. So we need to respect that as well. And once we respect that, we are going to build a world which is good for everybody. It's not just for us. Finally, intelligence, it's everywhere. We just need to learn how to look for it. Thank you.